Hi to everyone. Today we are going to discuss the topic called logical clocks in distributor system. This logical clocks is plays the main vital role because if there is a clock means there should be a synchronization. Without synchronization we can't send and receive the messages in distributor system. For that only it plays the main vital role. Each process maintain the logical value of a logical clock. So everything is having a LC value. That means a logical value of a logical clock. A logical clock is a process of P count how many event in a distributed computation casually produces the LC to the all the process. If suppose LC of E, the logical clock's value of process Pi at the event E. Suppose I am having a only one process, that every process is having every event is scheduled by means of numbering. That event value is scheduled by LC values. For an example, E1 is having a LC value 1, E2 is having a LC value 3, E3 is having LC value 3, and then 4, 5, 6. Likewise, every process is having a LC value. And then if a logical clocks is a system with more than one process of logical clocks is updated, how it is happening means there is this time scheduling. Time schedule is timestamp is also known as time scheduling. Each messages of M is sent to the timestamp TS. Okay, that TS logical clock value is associated with the sending events to the sender process. Suppose I am having a A1, that E1 is having a LC is equal to 1, that sends the message to the timestamp. Then timestamp of E1 is equal to 1. Likewise, every event is having a timestamp value. When the receiving process is received the messages M, it's updated to the logical clocks. That means it's calculated by means of LC and timestamp. That means the formula is used here is maximum of LC comma timestamp plus 1. That means event is scheduled, then timestamp. That means E1 is sent that times to the timestamp value, then the timestamp value can be calculated. This wants to be a minimum compared to a E2. Okay. Introducing the vector clock. The clock of each process is represented by the vector. The vector is a dimension of number of processes in the system. Each entry of the vector clock is corresponding to the process of P1, P2, P3. That means vector Vi is entered for the process P1, vector V2 is entered for the process P2, likewise V3 is also for the process P2. Using of vector clock, suppose a process P1 send the message to the process P2. That means a V1 send the message to V2, that the V1 should be a smaller one, V2 should be a greater one. If suppose there is a synchronization is happen. If suppose a V2 is send the message to the V1 wants to be a greater one. Okay. Then a meaning of the vector clocks. An entry of the vector clocks for the process P1 is the number of event Pi. VC1 is equal to 3, the number of event P1. VC2 is equal to 0, the number of event at P2. VC3 is equal to 1, the number of event at P3. P1 is known of the sure how many events is executed, but how can it sure about the P1 and P3? It can't, because yes, V1 can know only about a P1. We cannot update about the P2 and P3. So P1's of entry is P2 and P3 or the what P1 thinks about the P2 and P3. Because P1 thinks incorrect about the process of P1 is does not communicate with other process. P1 exchange the message with other process. It can update the information about the process using the vector clock timestamping. Because we cannot know about other process. By using the timestamping only we can receiving the message from other process, we can communicate each other. The timestamp here using like acknowledgement. That means I am sending the message to another process. It wants to wait particular time. Until that particular time, the other messages should not be communicated. So if it is receiving the timestamp, it send the messages. It like acknowledgement. So it send the messages till the timestamp is happened. Thank you. I think you all understand this concept.